So matrix multiplication, we're going to be doing first scalar multiplication, which should not be new to you. You've done scalar multiplication before. You did it last year in geometry. It's something you were amazed and wowed by, and you loved every minute of it, mostly probably because it was real easy. Okay? How many remember doing dilations last year?
I do. Making
things bigger or smaller. Dilations and reductions. That was scalar multiplication. So if you think of, for instance, the example, let me give you this one here. Let me find it here. Let's say this guy here. Number 4, this is in your book. Scalar multiplication is just multiplying a number by every element inside the matrix. So if I'm using scalar multiplication here, negative 3 times 15, negative 45, negative 3 times negative 12, 36, negative 3 times 10, negative 30, and 0. I want everyone to come up with the bottom row. Okay, what's this one?
Negative 60.
And this one?
30.
This one?
Negative 21.
Good. So negative 3 times 20, negative 60, negative or positive 30, negative 21, and 0. Good. Scalar multiplication. Difficult? Not so much. Pretty easy, actually. Matrix multiplication is more difficult. When I say let's multiply these two things together, it's more difficult. The book does a pretty good job at showing that on page 115, the best you can in a book that doesn't talk to you other than showing you an explanation. This is a pretty good explanation. They're saying if I'm going to multiply A by B, I first need to make sure that everything's lined up, and then I'm multiplying this row by that column, and then this row by the other column, and then the second row by the first column, second row by the second column, third row by the first column, third row by the second column. Okay, and you'll notice when they're multiplying first row by first column, they're saying 0 times 4 plus 3 times negative 2. And that gives you your element right here. This times that, 0 times 0, plus 3 times 1. That gives you that element. Now, I'm going to go through a process and show you maybe a good way to have a roadmap. But please note, multiplying matrices is much more difficult than adding and subtracting them. Okay, it's much more difficult than scalar multiplication. All right, so let's walk through a problem together. Let me give you one here. Let's try this one here. I want you to copy it down, please. Okay, once you have it copied down, just I use this a lot when I'm showing it to new students, and I expect you guys to use it as well, especially if you're struggling. Those of you who are, I do everything in my head, McCoy, because that's what I do, and it's worked for me forever, that's probably not going to work all year for you this year. In fact, you may catch you right here. This is going to be tough for you if you try to do everything in your head. You're going to make a lot of simple mistakes. I like to use the element name as a roadmap for what to multiply. Now remember, these are elements. Each individual piece in here is an element. Okay? So, with that being said, I'm going to give myself a little room to work here. So, I need to fold that over, maybe. All right. Give myself some extra paper because we definitely will need it here. Okay, the first thing you need to do is we're going to title this matrix A and this one matrix B. We're going to multiply A by B. Okay? And by multiplying A by B, we're going to get what we call matrix C. Why? Because we're creative like that. Yay. Okay? So matrix C. A times B equals C. In fact, I should probably have folded this over just a little more so I have more room. Either that or just tear the paper off. But there we go. All right, now I've kind of messed up my C, but I think you see. It's supposed to be a joke, yeah. Thank you for laughing. All right, there we go. You don't get it? Oh, you get it. Okay. First thing you need to do, multiply or show the dimensions. Everyone write down the dimensions of A underneath it and write down the dimensions of B underneath it. For those of you who are like, what are dimensions? You're a little behind, dude. Rows by column, you've got to study up what dimensions are. So how many rows? Two. How many columns? Three. Okay, how many rows?
3.
And how many columns?
3.
3. Before you ever multiply, make sure those two things match. The number of columns in the first matrix are the same as the number of rows in the second matrix. If these two numbers do not match, if they are not equal, you cannot multiply. If they are equal, that's good. We're happy. Well, at least you can multiply them. You may not be happy you can multiply them after you see what multiply entails, but you can actually multiply. Then, if that's true, you look at these two numbers and compare them, because those two numbers are the dimensions of your new matrix, the product matrix. So our product matrix is going to be a 2 by 3 of a lot of importance to us, because when we're actually calculating the product here, I want to show my product matrix. I'm going to show the work over here. So I know it's a 2 by 3. I want to make sure I stay on the screen for you. But give yourself plenty of room. I'm going to show a work matrix here. Okay, where I'm actually going to show my work. I know this is going to be a 2 by 3 matrix over here. So it's going to have 2 rows and 3 columns. So there are my 3 columns. Those are my 2 rows. Okay, 2 by 3. Now, since we called this matrix C over here, I'm going to title I'm going to give each of these elements a name. Now, those of you who don't like to show work, you're going to refuse to do this right now. And it's going to be tough on you. I promise. I'm not just telling you that to scare you into it. Okay, it's important that you're going through it. This is called C. What element name? C what? 1, 1. This is C 1, 2. And C row 1, column 3. C row 2, column 1. C row 2, column 2. And C row 2, column 3. Those are the elements. Those elements also work as road maps for me now. They tell me what to multiply. This says row 1, column 1. That means I am multiplying row 1 of my first matrix by column 1 of my second. They tell you what to multiply. So when I'm trying to calculate this element, this position right here, I'm going to go 1 times 2. So row 1 by column 1. 1 times 2 is 2. Okay, and actually I'm going to write down what I'm multiplying so you guys can see that. You don't have to do that, but 1 times 2 plus 0 times 0 plus -5 times 0. Okay? Now, like I said, you don't have to show all that. If you just want, you could just put, that's just 2 plus 0 plus 0, or 2, right? So the result there is 2. So cell C11 has an element of 2. So I'm going to actually put my actual end result matrix right here. This is going to be my answer when I'm done. Okay? How many are with me? All right. Let's do the next one. So this tells me I am going to multiply row 1 by column 2. So same row, but different column. So now I'm going 1 times 4 plus 0 times 10 plus -5 times 1. Okay, so 1 times 4, we get 4, plus 0 times 10 is 0, plus -5, or -1. So C12 is -1. Now you don't have to keep putting the elements there forever, but for now it just kind of gives you a nice road marker. Okay, this one I'm doing row 1 by column 3. Okay, so once again, same row, different column this time. Okay, we now go 1 times -2, or -2, plus 1 times, actually let's put that 1 in there. Okay, 1 times -2 plus 0 times 4, and plus -5 times -7. All right, which is -2 plus 0 plus 35. That should be a -7. Kind of looks like it carried in there. That gives us negative, or positive, excuse me, 33. C13. Any questions up to that point? All right, I want everyone to figure out the bottom row, please. All right. So we're now on row 2, right? So all this stuff I was using in column A, or in row A, row 1 of matrix A, is now goes down there. And I do the process all over again. So I got 2 times 2, or 4, -1 and 0, or 0, and 6 and 0, or 0, or a total of 4. Okay, let's see row 1 or row 2, column 1 now. Okay, C row 2, column 2, and C row 2, column 3. Okay, go through that same process. Okay, there, and there. So 2 times 4, or 8. -10 and 6, which gives me 4. A lot of 4s. All right. Then row 2 times column 3, so -4, -4, and -42. For a grand total of -50. Is that what everyone got there?
Yeah.
All right. So there's our matrix. Okay, everyone rate yourselves 1 to 5 now. You got it? Okay. Any questions? So here's my question for you now. This was A times B, right? Could I do B times A? Talk to your neighbor, yes or no, and why or why not. How many say yes? No?
No.
Why is it no? Don't give me a good reason there. Claudia?
Because the columns in B are the same as the rows.
Okay, so your A, or excuse me, your B is 3 by 3. Your A is 2 by 3. Keep putting parentheses there. 2 by 3. Your columns in B are not the same as rows in A. They are not equal. That means you cannot multiply them. Think of it this way. When we were going through this process up here, we're saying this goes with that. That goes with that. That goes with that. Right? Each element of a row must have a corresponding element in a column. That's why these two things have to be the same. Otherwise, you'll have 3 and only 2 in the other. It'd be like, 3 couples going to a dance, however, one of those couples only has 1 person. That's sad. Yeah, I know, dude. That's like, oh, hey, how you guys doing? It's not fun. So, then you have, all right? So I think you get the point. Make sure that that's true first. Otherwise, it's not possible. You're done. So, is matrix multiplication commutative? No. Usually, everything you've studied in math so far, multiplication's been commutative. It's not in matrices. It's not commutative. 2 times 3 does not equal 3 times 2 when you're dealing with matrices. Okay, they're not commutative. It's a different type of multiplication. Okay, any questions there? Why don't you take a look at your assignment, please? So everyone's looking at that. Okay. So, to begin with, you're only doing the example side today. Now, do not cross out the mixed side. That's going to be tomorrow. But example side today. All right? And on the example side, here's the answer book. On the example side, please note that the first part, problems 1 through 5, deal with scalar multiplication. 6, 7, and 8 are really matrix multiplication that we've been doing. They don't look too terribly challenging, however. 9 and 10, make sure you read the directions. Otherwise, you might get upset after you do them the wrong way. Numbers 12 and 13 say use your calculator. I would suggest you try 12 before you leave today, because some of you are going to struggle with that once you get it into your calculator. Okay? So if you have your graphing calculator, take it out right now. Right. If you turn on your calculator and you go to your matrix menu, and you're trying to enter a new matrix, some students get really hung up with the fact that they have things in their matrix already. So some students they're like, how do I get rid of those? And one way to do it is just click on edit and go to that matrix. And if you're trying to put in, say, this matrix, your first matrix here, as a 3 by 2, you just change your dimensions, 3 by 2. Oops, not 32. 3, delete, 2. Okay, and then you know 0.8, 9.12. 0.9, 10.34, 0.3, and 8.27. Okay? Now, I have that matrix in there. If you are someone who well, it looks so messy. Okay, I don't even use B anymore. I don't use this one, and I have something in there. It's messy. Can't I just get rid of that so it doesn't say that? I like my calculator clean, dude. Okay, I need to have it clean and perfect. So maybe you have some tendencies to type A personality. Okay, if that's you, that's okay. But what you do is, if you want to get rid of, say, just B or all of them, I was told last period, hey, you could just clear all your memory and they'll all disappear. Okay, you could try that. That's fine. And I'm going to do second memory or second plus. And then I'm going to go down. So if you want to do 7, 1, 2 now, that will erase everything. But I'm going to go down to number 2. And when I select number 2, it starts calculating. Notice this little thing that's moving there, or was moving. It means it was working. I'm going to go down to matrix, option 5 on mine. Okay, and now it shows me the matrices I'm using. I have something in A. I just put stuff in A. I had something in B. If I want B gone, but I want to keep A, I just move my cursor to B and hit delete. And now B is empty. Now, if I hit delete for A, what I just put in is going to disappear. So I don't want to do that. So now if I go back to my matrix menu, notice B is clean. It's empty. It's all nice and pretty for you.
Yay!
Yeah. Okay? So you can put in B now. Now that you've emptied B, you can now put something in B. Oops, I selected A. So I'm going to go to B, and I put my 3 or 2 by 4. Okay? So 7.2, negative 8.23, my 4.5, 0.12. I just set it on my desk. Thank you, Hannah. Have a good trip. 43.2, 54.2, 65.8, and 89.1. You'll notice my matrix automatically scrolls over for me. And quit. Now here's the problem. That's not where students struggle. They struggled with this. After you get your matrix and you select your matrix, A, and so make sure you know which one you're multiplying. If I called this one A, this one's B, I need to multiply in that order. A times B. So A times, if you could put the time sign, that's fine. If you don't, it'll still calculate it as it. B, and then hit enter. Now, when you see that, you're like, oh, hey, where are the rest of my answers? And some people may just try to go up there and start. They're like, hey, it won't go over. It won't go over. It won't, look, it won't go over. This happened last period. So I'm like, oh, let's go down arrow. See? It doesn't go over. Okay, it doesn't go over. I believe you. Okay? So let's recalculate. What, I got to select all that again? No, if you go to second, enter, it automatically gives you your last entry. In fact, if you keep hitting second enter, it'll just scroll through all your entries. But then I hit enter again. Now, before you get all anxious about highlighting it, just push over now. I know. Now, at any time, if you go up and highlight that and try to go over again, it won't do it again. That's a quirk in their operating system, I guess. We just found that out last period. Okay? So that's how you get all your answers. Any questions? Okay.